I'm Arn from the Maagdenberg. I'm a professor of neurogenetics, and my interest is in various neurological diseases, including migraine, alternating hemiplegia of childhood, and hemiplegic migraine. So the idea is to identify genes for these disorders and then try to find out why certain mutations cause the disease. And for that I use transgenic mouse models. So I was interested already for quite some time in alternating hemiplegia of childhood. I was involved also in the gene hunt, which led to the first gene, the ATP1A3 gene, that is now so well studied. The interest for me now is to identify a gene, a novel gene, in patients that do not have a mutation in the ATP1A3 gene. So they have the same phenotype, or almost the same phenotype, but we cannot identify a molecular cause. And I'm very interested in this huge international collaboration of sites in Europe, in Asia, in the US, to jointly try and find this cause. Because if we have such a cause, an additional gene, we may learn more about what causes AHC. And if we do, then this opens up maybe new avenues to look for new therapies. This is going, let's say, slowly, much slower than finding the first gene, which in the end turned out to be a walk in the park, actually. But the harder things are sometimes more rewarding, so we really try and work together. We did identify the first clues, and we were discussing them amongst each other. But the proof that we have identified a second gene, or whether it even exists, is still out there. So what would be necessary to find such a gene? That is that we work together. We already found out in the last few years that if you work on your own, in your own lab, you just have two little cases to be able to tell which gene is actually the causal gene for AHC in these patients. But if you join all the information together, then we hope that certain genes pop up. And that's exactly what's needed. So we're doing our best to work together, but let's say communication is everything. So I think that is what we need, to communicate better and then trust each other, and hopefully that will lead to a second gene in the near future. We identified the first gene, the ATP1A3 gene, and everybody asks, when will be the next big breakthrough? So there are a few dreams that I would have, and I hope they come soon, but as you can never predict research, I can't tell when this will happen. I would like to know exactly what's wrong with the pump. And if I know that, I want to know which researcher think they have a means to correct that change. And if that's, let's say, known, then we can really think of approaching companies, for instance, that have drugs that may interfere with the pump, and do trials in that sense. So the genetics may help because we know which patients have a mutation and we can categorize them. So I hope that the genetics people will be involved in the new, let's say, era of the research on this pump. It turned out very hard to identify the second gene, and we are collecting patients with a set of criteria that fulfill the diagnosis of AHC. And the first thing I would like to do is have them tested for the ATP1A3 gene, because that is important to do more clinical research. But I'm equally interested if we can't find an ATP1A3 mutation, because these people could enter the program where we try to identify the second gene. The more patients we have with a good diagnosis of AHC, the more chance we have to find enough of them that have a mutation in a particular gene. So that sticks out, and that gene then will be, let's say, logically the next AHC gene. I'm still amazed by the success of the gene hunt where we identified the sodium-potassium ATPase. So we have a few mutations that apparently seem to cause a specific phenotype, alternating hemiplegia of childhood. And now the research is moving on. We seem to identify exactly what goes wrong with that pump. So what we really would like to know as a consortium is how to correct the conformation of the protein that causes these severe phenotypes. So maybe there are people out there that have specific compounds that interact with the sodium potassium pump, and we can test them in our functional assays. And maybe we find a compound that helps correct the pump. And that could be, let's say, an avenue for new therapies. So for the last few years, we have been collecting many AHC patients, and we were particularly interested in those that didn't have a mutation in the ATP1A3 gene, because we figured if we would use the same strategy as we did for the first hunt, maybe we're lucky to find an additional gene, the second gene for AHC. So what are we doing? We try to identify patients, and for that we need the doctors, of course, and then we collect the DNA of the patient, but also of the parents. And the idea is if the patient has a mutation in a particular gene, but the parents who are normal, don't have a clinical phenotype, do not have that mutation, that's evidence that that gene is indeed involved. And that was exactly what happened with the first gene, the ATP1A3 gene. And we are now collecting many of these trios, as they are called, and sequencing them in a collaborative effort with many groups in the world, to just identify more of these patients-parent combinations that have a mutation in the same gene. And if we have a number of those, that is enough evidence for us to pursue this as a second gene, and hopefully that gives us new information on what kind of pathway is involved in AHC. So we have been sequencing these patient-parent trios, trying to identify mutations in a gene that is present in the patient but not in the parents. But what we are doing at the moment is only look at the patients with AHC. So there must be data out there of other diseases with epilepsy, hemiplegia, that we could make access or get access to, and then combine with the data that we have from AHC. And hopefully by combining information of different patient groups, we are so lucky that a picture emerges and that we do identify a second gene. That's one of the hopes I have for the next few years. So if there's data out there of patients and their parents of different phenotypes, not the same perhaps as AHC, but related to it, like an epileptic phenotype or some of the hemiplegic phenotype of some kind, would be great to get into contact with them, because that kind of information we can merge with our data, and maybe we can help each other. Our data may be of use to the other community and vice versa. That would be something really cool for the next few years. AHC is a very devastating disease, and as a parent, I cannot even imagine how difficult it will be to cope on an almost daily basis with your child being affected with these severe attacks. But what I hope is that people keep, let's say, connecting to clinicians and scientists, because one should not lose hope, and there's always the idea that there is a drug out there. It just takes so much time and energy to put all the pieces together, and hopefully we'll have success in that area soon.